Hey guys, this is Coach Lowe, and we are talking trig still. Yay! And we are in Chapter 8, Section 6, and we are going to break Section 6 into two parts. So today we are going to talk about law of sines. Yes. All right. So law of sines is used when we're dealing with a non-right triangle. And we can use this when we're trying to find missing sides or missing angles. And it works with angle, angle, side, or angle, side, angle. It also works with side, side, angle. So if you're given two sides and an angle, but you have to be careful about that because there's an ambiguous case, which we will talk about later, where you could end up with two triangles. And then tomorrow, or I shouldn't say tomorrow, in the next video, we'll talk about law of cosines that we'll use when we're given three sides or two sides and the angle between. All right, so let's just stick with the law of sines for now. So let's say that I'm given a triangle. Let's say it's triangle ABC. So there are my angles A, B, and C, and then my sides opposite. So opposite capital A is little a, that's its side. Side B goes opposite angle B, and there's side C. All right, so the law of sines says that the sides and angles are proportional to each other. So it looks like this. The sine of angle A over side A, that proportion is equal to the sine of angle B over side B, and that's equal to the sine of angle C over side C. Now we won't use all three of these proportions at once, but you can see that if we group two proportions together, if we know three of the four, we could solve. So here, if I know three of the four, like two angles and a side, we could solve. Here, same thing. All right, so let me give you one and we'll plug and chug this bad boy. So non-right triangle, if we have right triangle, we know we can use our right triangle trig. We can pull out the SOHCAHTOA stuff and get after it, right? But this is a non-right triangle. So this is triangle PQR. No right angles in this triangle. This angle is 29 degrees. This angle is 17 degrees. And this side is 8. So first we want to look at, okay, what are we given? What do we have? Well, we have angle R and the side opposite. We have angle P, and let's try to find side P. All right, so we're looking for side P. All right, so I'm going to use the law of sines. Sine of angle R over side R is equal to sine of angle P over side P. Now I use these guys because I'm given 3 out of the 4. All right, so we have the sine of 29 degrees is angle R divided by side R is equal to the sine of angle P over side P. All right, if you'd like to pause the video at this point, you know how to solve these proportions. We've been doing this for a while, so go ahead and pause it and try to tackle this problem. Okay, now that you're back, let's go ahead and solve. So when I cross multiply here, I have P multiplied by the sine of 29 degrees is equal to 8 multiplied by the sine of 17 degrees. Dividing both sides by sine 29 degrees, sine of 29 degrees. And then we pop this in our calculator. Remember, make sure your calculator is in degree mode. So 8 multiplied by the sine of 17 degrees divided by the sine of 29 degrees, and let's round to the nearest tenth, I get 4.8 for side P. All right, so what if they want the rest of the angles in the sides? Well, we know that 3 angles in a triangle add to be 180 degrees. So to find angle Q, I could do 180 minus the sum of the other two angles. So add the other two angles together and subtract from 180. So 180 minus 17 and 29, we know that 17 and 29 is 46. And that gives us 134 degrees for angle Q. Now that we know the measure of angle Q, we can find the length of side Q by setting up law of cosines again. So sine 134 over Q is equal to sine 29 over 8. So we would just replace this stuff right here with sine 134 and Q. And we would do the exact same thing. All right, go ahead and try that and see what you get. And I'll check in with you next time I see you on that answer. All right, so make sure you show me that triangle. This is example number 1. So show me that triangle and let's see if you got side Q correct. All right, let's try another one. Example number 2, go ahead and draw this triangle with me. So we have triangle ABC. Now I'm missing an angle. Notice now I have angle, angle, side. All right, so let's go ahead and find this angle here. All right. So I have angle A, side A, angle B, and side B. Sorry, side B is 10. We need one more thing, don't we? So this is side B. All right, so I have sine of some angle, theta, over 11 is equal to sine 50 over 10. So let me highlight those again so you can see that if you're not catching on here. So I have sine of this angle over its side length, that's the first proportion, sine of this angle B over its side length. And remember, we're going to the opposite side to pick up the side length. I wrote 11 instead of 10, didn't I? Thank you for catching that. All right, so sine theta over 11 is equal to sine 50 over 10. All right, so now we are solving for this angle. So we can cross multiply, or you can just multiply both sides by 11. Sine theta is equal to 11 multiplied by sine 50 over 10. So cross multiply and then divide. All right, now we have talked about this. These are connected together, so we have to take sine inverse in order to get theta by itself, and we must do that to both sides. So theta now is equal to sine inverse of 11 sine 50, 11 multiplied by the sine of 50 degrees divided by 10. So remember, sine inverse is that second sine key on your calculator. So shift sine, and then we can put all this stuff in, 11 times the sine of 50 divided by 10, and you should get theta is 57.4 degrees. 57.4 degrees. All right, let me grab one more. So this is example number 3. Draw this triangle with me. All right, we want to solve the triangle, which means we are going to find all 3 sides. We'll find little c, we'll find little a, and we're going to find the measure of angle B. All right, so we'll find all 3 of those. All right, first of all, I noticed that I have 2 angles, which means I can definitely find the measure of angle B, can't I? The measure of angle B is 180 degrees minus the sum of the other 2 angles. So 32 plus 71 is 103, and we'll subtract that from 180 degrees. All right, so the measure of angle B is 77 degrees. All right, so now that we know the measure of angle B, can we use law of sines? Absolutely we can, because we have side B. So sine of B over B, so sine of angle B over side B is equal to, and then we can use either one of the other two angles because we have to find both sides. So let's start with angle A. Sine of angle A over side A. So let's fill in what we know. Sine of 77 degrees, I need to clean up my writing here a little bit. Sine of angle B, which is 77 degrees, over side B, which is 8, is equal to sine of angle A, which is 32 degrees, divided by side A, which we don't know. All right, let's go ahead and solve these guys. So cross multiplying A multiplied by the sine of 77 is equal to 8 multiplied by the sine of 32. Solving for A. So we want A to stay here. This is multiplication, so let's divide. We'll get this calculator ready, won't we? So A is equal to 8 multiplied by the sine of 32 degrees divided by the sine of 77 degrees. All right, so pop that on your calculator. If you have an iPhone, you know you can turn your calculator sideways and you can get this, you can get the calculator that you need, the trig, functions on the calculator, so that's very handy. If you don't, then I'm sure there's a free app that you can find that will help you be able to find the lengths of those sides. All right, so we should have 8 sine 32 divided by sine 77. All right, so let's round that to the nearest tenth. And rounding to the nearest tenth, this is about 4.4 for side A. And side A is also the length of segment BC. So watch for that on standardized testing like the EOI. It may say side BC instead of side A, and that's totally fine. Not a big deal. All right, so let's go ahead and find side AB, which is lowercase c. All right, so we have sine of B over B is equal to sine C over C. Could I have used sine A over A with sine C over C? Absolutely, not a problem. All right, so sine of 77 over 8 is equal to sine 71 over C. And so I have C sine 77 is equal to 8 sine 71. C equals 8 sine 71 divided by sine of 77. That's a lot of sevens, isn't it? Woo. All right. So now we can pop this on our calculator, and side C is about 7.8. Side C is about 7.8. So those are side lengths, not degree measures. We found angle B is 77 degrees, side BC is 4.4, side AB is 7.8, and we have solved this triangle. We are finished. All right, guys, that's part 1 of 8-6. This is Coach Lowe, and I'm out.